Hello class 6. Today in this video we are going to learn the basic terms of algebra. In the chapter Fundamental Concepts of Algebra, we first need to understand what are the basic terms that we are going to use in our chapter. So the first thing is constants. These constants are the quantities whose values are fixed. Okay, fixed means their values will not change with any situation or any condition. Example 2, 5, or any fraction like 5 by 3, 7, 1 by 4. These values are not going to change whether there is any change in condition or in any situation. These values are going to remain fixed. So 2 remains 2 forever. Okay, 2 cannot be changed to something else with a change in condition. Similarly, 5 or any other number remains same. So these quantities are fixed. So that's why they are called as constants. Variables in the other place are the quantities whose values are not fixed. The values of the variables varies. That's why they are called as variables. They vary means the value will change. For example, if I take any value like x, okay, let's consider x. Let's say the value of x is 2 in a particular situation. Then in another condition or another situation, the value of x may change. It may become 100, it may become 1000, 150. So these values, these quantities can change their value. So x, y, z, you can see most of them are alphabets. Okay, so these alphabets represents variables, and these variables, they don't have any fixed value, so their values may change. Similarly, over here you can see 2x, where 2 and x are, where 2 is a constant and x is a variable. 7 is a constant and y is a variable. You can see 2 and x. Suppose if I say the value of x is not fixed, okay, if the value of x is not fixed, then the value of 2x is also not fixed. Then in that case 2x also is considered as a variable. If x is in first condition, let's say the value of x is 5, then the value of 2x will be 2 into x, that is 2 into 5 will be equal to 10. But if the value of x in the next case changes to like 10, then the value of 2x becomes 20. Similarly, 7y is also a variable. Why? Because the value of y is not fixed. That's why, since y will change, the value of y may change. So that in the similar way, the value of 7y may also change. Similarly, 5m or any term with any of the number. Okay, like let's say 12 is a number and it's connected with any of the value like 12a. Okay, so 12a, since a is a variable, 12a also becomes a variable. Next we have terms. What is a term? A term is either a constant or a variable. Okay, a term can either be a constant or a variable. For example, 4 over here is a constant, but also we'll call this 4 as a term. Similarly, x is also a variable and x also represents a term. 7a, where 7 is a constant, a is a variable. Together 7a is a term which is a variable. 13x squared, x squared, x is a variable, that's why x squared becomes a variable. 13 is a constant, but since it is multiplied with x squared, that's why the whole term becomes a variable. Alright, so the term actually means it's either a constant or a variable. So in this case, these are the taken examples. Similarly, we have like terms. Excuse me. Like terms are those terms with the same variables. If you look at the examples, you will see that 5x, 7x minus 4 by 5x. These are the like terms over here. Why? Because all these variables are same. The variables over here taken are x. Okay, so 5x has the same variable, 7x, x is a variable, minus 4 by 5x, x is a variable again. That's why these are the group of like terms. Similarly, over here in the second case, we can see the variable is a. So 13a minus 4 by 7a, 15a becomes like terms. You don't need to consider the number in front. Okay, you just need to consider at the variables. If the variables are same, then we consider those terms to be as like terms. Over here, the next example is 14ab, 73ab minus 2 by 3ab. See, the variables are same. That's why all these terms are considered as like terms. Next, unlike terms. Terms with different variables. You can see that there are different variables out here, a, b, m, x squared, x. You can have any variable out here, but those variables should not be the same. If the variables are not same, if they are different, then we consider the terms to be as unlike terms. All right, so like terms and unlike terms. Next, we move on to expressions. A group or a collection of terms which are connected by either a plus or minus signs is considered as expressions, or in other words, we can call them as algebraic expressions. For example, 4x plus 3y is an algebraic expression. 4x and 3y plus 3y is considered as algebraic expression because they are connected by a plus sign out here. So 4x is a term, 3y is another term, 4x is a term and 3y is another term. So together they form an expression. Similarly, 7a plus 2b minus 6c becomes an algebraic expression where they are connected by either a plus or minus signs. Similarly, 4 by 3 x square y minus 17x square, this also forms an algebraic expression where both the terms are connected by a negative or a minus sign. Next, have a look. Since these terms are connected by either a plus or a minus sign, okay, so we can classify the algebraic expressions into different types. The first type is a monomial. Monomial is an expression which has only one term. Alright, so over here the example taken is 4x. 4x itself is a single term. 5x square y, another single term. 2 by 5xy, another single term. So all these single terms are the monomials. The monomial means those expressions which has only one term. Similarly, binomial, the term bi stands for two. So binomial means an expression with two terms. So those expressions with two terms over here, 4x and 5y is connected by plus, 3 by 2x minus 4 by 11y connected by minus sign. They form an algebraic expression which is a binomial. 8 minus 2a is another binomial. Next is trinomial. Similarly, trinomial represents the algebraic expression with three terms. Over here the example is a plus 2b minus 6c. All right, so there are three terms separated by plus and minus sign. 4x square minus half y plus 3. So again over here there is a minus sign and a plus sign which separates the terms into into three terms. So they are trinomials. Now, multinomial are the expressions which are more than one term. For example, if there are two terms, it's a binomial, right? If there are three terms, it's a trinomial. So monomial, except monomial, all those expressions like binomial, trinomial, okay, all these expressions more than one are considered as multinomial. Alright, so 4x plus 6, since it's a binomial, it's also a multinomial. This expression 18x square minus 4 minus 8y is a multinomial because it's a trinomial. Any expression which is more than one term, okay, it should not be a single term, but it should be more than one term, then it will represent a multinomial. Next one, polynomial. Now every monomial or multinomial is a polynomial. Everything that we have been studying now, okay, monomial, binomial, trinomial, multinomial, everything is a polynomial. Okay, only the thing that you need to remember is that the power of the variables must be a whole number. All right, that means let's say that you have 4x. 4x is a monomial, all right, and the power of x over here is nothing written, that means the power is 1. Okay, and what is 1? 1 is a whole number. So the power of this variable 4x being 1 is a polynomial. Okay, but if we consider as 1 by x, see 1 by x, x is in the denominator, okay, and if we take this x up, okay, in the numerator, the power of this x becomes negative. Okay, that is over here the power of x is 1, so it becomes minus 1, and negative number is not a whole number. That's why 1 by x is not a polynomial. All right, so all those terms with the power of the variables being 0 or any positive number will represent a polynomial. Okay, simply if we take a number like 5 itself is a polynomial. Why? Because there is no variable. Okay, that means the variable's power is 0. In this case it's a polynomial 5. Okay, but anything like 5 by a square does not represent a polynomial, because 5 by a square means 5 a square, but the power, that this power 2 will be negative. Okay, 5 a to the power minus 2 is not a polynomial because it does not represent a whole number. The power does not represent a whole number. All right, so basically what we have learned is that in order to separate out different terms, in order to know in an expression how many terms are there, basically we look forward for plus or minus signs. Okay, we don't consider any term being connected by multiplication or division signs. Like 4x multiplies with 5y, if you see that there are two terms being connected by a multiplication sign. Okay, and what have we said? That it may not be separated by multiplication or division sign. So over here multiplication sign means we can multiply them as 4 into 5 as 20, x into y will give you xy. So 20xy is not a two term, it's not a binomial, it's a monomial, so it becomes a single term. So 4x into 5y are not the two separate terms, but it becomes a single term. That's why we don't consider any of the terms being connected by multiplication or division signs to be as separated as a separate terms. All right, so it has to be separated by either plus or minus signs only, not by multiplication or division signs. Similarly, if I say like 10y being divided by 5, okay, you may think that 10y is a single term, 5 is another term, and they are two different terms, so they must be two different terms. But actually 10y divided by 5 will give you, 5 will divide 10 two times and you will get y, so 2y becomes a single term. Hence we don't consider any two separated any term separated by multiplication or division signs to be as actually being separated by those terms, by those signs. Okay, but in this case 4x minus 5y, 4x minus 5y represents the two separate terms. Over here you need to remember that they must be unlike terms. If 4x minus 5x, suppose if the two terms are separated by a plus or minus sign, but the two terms are the same like terms, then again they may be simplified into a single term. So over here they are like terms and they are separated by plus or minus sign does not mean that they are actually separated. Okay, because they can be simplified into a single term. Alright, but over here 4x minus 5y, since both the terms are unlike terms and being separated by plus or minus signs means they are actually separated. 7x into 4 minus 5m plus 2y, over here these two terms are actually a single term because it's a multiplication sign. Minus 5m another term and plus 2y another term, so there are total of 3 terms. So that's why it's a trinomial. Alright, so whenever we are looking forward for how many terms a given expression has, we only look forward to how many plus and minus signs are they all together in that expression. Suppose if there are one sign, one plus or minus sign, then there may be two terms. Over here we have one minus and one plus sign, that means we have two signs. Okay, so two signs will give you three terms. Okay, that is one extra. If there are two signs, that means there will be three terms. If there are four signs, then there will be five terms. Okay, so in that way we can separate out the given expression into different terms. Next we have coefficient. All right, coefficient of 5x, y and z. Suppose if we have to find out what is the coefficient of 5x, then leaving this 5 and x, if we just block this 5 and x, what do we get? We get y and z, yz. Okay, so the coefficient of 5x is equal to yz. In 5x, yz, what is the coefficient of 5? If you need to find the coefficient of 5, just block it, just hide this 5. Whatever is the remaining will be the coefficient. So x, y, z is the coefficient of 5 in 5x, y, z. What is the coefficient of z? So just block z. So the remaining 5x, y will give you the coefficient of z. All right. This 5 being the number in front of these variables, 5 is called as a numeral coefficient. Okay, so 5 is the numeral coefficient of 5x, y, z. So any given term, like let's say 7a square b, 7a square b has 7 as the numeral coefficient. Okay, next is power. We all know that when any term gets multiplied with the same term, then we write it as like x into x gives x to the power 2. So this 2 is called as a power. Similarly, a into a into a into a into a, how many a are there? If you count, there are 5 a's. Okay, so we write it as a to the power 5. So this 5 is the power. So whenever there is any number at the base, we call it as a base. Okay, and it's the power is written on top. Then a to the power x, where x is called the power, or also called as the exponent, or is also called as the index. Okay, so a to the power x, or a exponent x, or the a with index x. Okay, a is the base and x is also called as power or exponent or index. Now we'll start with the exercise 18b. See, the question number 1 is very easy. We have to separate the constant and the variables. Just write constants and give a dash and write down all those terms which are constants. Alright, what I can see over here is 6 is a constant. Alright, 4y is a variable, minus 3x is a variable, and so on. So just write down constants and write down all those terms which are constants. And in next you write down variables and write down all those terms which are variables. Okay. Number 2, you have to group the like terms together, as I have said earlier. Okay, the like terms are those terms with the same variable. Over here you can see that 4x, x, all these x terms are the like terms, and this y terms are another like terms. Okay, so there are two sets of like terms. So in here, in this question number 2, you need to separate out the like terms. All right, so you can do question number 1, question number 2 by yourself. Leave question number 3, that is true or false, for the time being. We'll do it later on. Look at question number 4. State the number of terms in each of the following expressions. So how many terms are there, you need to find out and just write the number. Okay, so 2a minus b. Okay, 2a minus b has two terms out here, 2a and b, separated by a minus sign. So 2a and b, since there are two terms, so we'll write the answer as 2. Here you can see 3 into x plus a by 2. So 3 into x plus a by 2, there is a multiplication sign out here and a plus sign. Okay, only the plus or minus sign separates the terms. So only this plus sign is separating these term 3 into x and a by 2 separately. So that means there are total of 2 terms. Similarly, you can find out the number of terms. And one more thing I would like to clear out. We don't write in algebra, we don't write x like this. Okay, this is a multiplication sign. How do we write x is, we write x this way. All right, like this and like this. We don't write x like this because it's a multiplication sign. So from now onwards, whenever you are writing x, please try to write it this way. So this is the way we write x. Similarly, there are lots of alphabets being used in algebra. All right, so we don't write L also like this because this represents 1. Okay, this is a 1. Okay, most of you write 1 like this. So in order to write L, we write L like this. Okay, just remember your cursive writing, L. Similarly, don't write T. Whenever you have to write T, don't write T like this. This is a sign of plus. So basically we write T this way. All right, T. Okay, next, we don't write Z also like this. Okay, some of the people, they write Z this way. Okay, it represents 2, and some of them might write Z like this. If you don't end up with this tail going up, okay, this may look like 3. So how do we write Z? So we write Z right like this and give a small stroke out here, so it represents Z in algebra. All right, similarly 5 is this and this is S. Okay, 5 and S look similar, so we write S like this. Okay, so these are the basic things that you need to remember. Most of the people, they make mistake while writing X. They write X this way. So we don't write X from now onwards in mathematics like this. Okay, we always write X in this manner, We always write L in this manner. We always write T this in this way. Okay, Z in this way, S in this way. Okay, so these are the things that you need to remember while you are doing your work. Also, lastly, do question number 6, where you have to separate out monomial or a binomial or a trinomial. Over here, xy is a single term, so it's a monomial. Xy plus x, there are two terms separated by 1 plus sign, so xy plus x represents a binomial. 2x divided by y, there is no plus or minus sign, so 2x divided by y will give you 2x by y. So 2x by y is not a binomial, it's a monomial. So similarly, you can write down how many terms are there. In a similar way, you can separate them out as monomial or a binomial or a trinomial. So your homework is question number 1, 2, 4 and question number 6. All right, so that much for